Now this example is basically an accident. So I was in the local variable section and I wanted to find the load byte assembly instruction. And I was creating things to try to find that, and I came up with this and I found it. But then as I was writing up the stack diagram for that, I was like, oh crap, there's the argc and argv. I can't cover this until we cover calling functions and arguments, and you have to be able to understand that there's two arguments coming into main so that you understand what A0 and A1 are when you see them used in main. What I just realized as I was going to record this is that neither argc nor argv are actually used in this code. There was literally no point for them to be here. I could have deleted them and put this back in the section, but I had already reordered things, renumbered the little stars and assembly instructions, and it was going to be super annoying to renumber them back. So I left it where it was, but you're going to get an inadvertent introduction to the argc and argv usage when passed into main. Here's our compilation, no stack protector as before, and here is our load B, load byte, and sub W. So two new assembly instructions. Let's cover those first. So here's sub W, subtract word register from word register. So the W suffix is your hint that you're looking at an RV64I assembly instruction that wants to operate on word registers, 32-bit registers, rather than its native 64-bit register. So this is written as sub W, source 1, source 2, destination, and it takes the bottom 32 bits of source 1 minus the bottom 32 bits of source 2 and stores it into the destination register. That 32-bit result, so the subtraction is operated on as a 32-bit result, gets the result, and then sign extends it up to 64 bits. And as I said, this is what RV64I code uses when it wants to operate on 32-bit or word-sized variables, such as integers. Then we have the LB, the thing we were looking for before, load byte, not load byte unsigned, from memory to register. So this is now going to do source plus immediate 12, which is going to be sign extended as usual, because this is a signed immediate. Source plus sign extended immediate 12, treat that as a byte address, and then sign extend the result to the 32-bit register, or 64-bit if you're running 64-bit code. So we are looking at a sign extended result rather than a 0 extended. We saw load byte unsigned before, that's 0 extended. This is load byte, which is signed and signed extended. For whatever reason, GCC really prefers to use LBU rather than LB, and I have to go out of my way to create an example that I could get it to create the LB with. Now it's time to draw your stack diagram, but the very important hint is that you are looking at a main that is taking two arguments, a integer argc and a pointer argv. So a character pointer. So it's a pointer that points at something that points at an array of character pointers terminated by a null terminator. So stop, step through the assembly, be very careful with what there is around. Go ahead and, do extra dereferences and stuff if you get confused over what anything is, but draw that stack diagram and come back and see how it should look.